Motion, in physics, change with time of the position or orientation of a body. Motion along a line or a curve is called translation. Motion that changes the orientation of a body is called rotation. In both cases, all points in the body have the same velocity, directed speed, and the same acceleration, time rate of change of velocity. The most general kind of motion combines both translation and rotation. Key people: Thomas Hobbes, Galileo, Gottfried Wilhelm Leibniz, Jean Buridan, Pafnuty, Chebyshev. Related topics: Brownian motion, wave motion, vibration, phase action. All motions are relative to some frame of reference. Saying that a body is at rest, which means that it is not in motion, merely means that it is being described with respect to a frame of reference that is moving together with the body. For example, a body on the surface of the Earth may appear to be at rest, but that is only because the observer is also on the surface of the Earth. The Earth itself, together with both the body and the observer, is moving in its orbit around the Sun and rotating on its own axis at all times. As a rule, the motions of bodies obey Newton's laws of motion. However, motion at speeds close to the speed of light must be treated by using the theory of relativity, and the motion of very small bodies, such as electrons, must be treated by using quantum mechanics. Isaac Newton. Read more on this topic. Philosophy of physics, the question of motion. Long before Kant, Newton himself designed a thought experiment to show that relationism must be false. The editors of Encyclopaedia Britannica. This article was most recently revised and updated by Adam Augustyn, managing editor, reference content. Learn more in these related Britannica articles. Isaac Newton. Philosophy of physics, the question of motion. Long before Kant, Newton himself designed a thought experiment to show that relationism must be false. Aristotle. Motion, kinesis, was for Aristotle a broad term, encompassing changes in several different Babylonian mathematical tablet mathematics. The university's uniformly accelerated motion starting at zero velocity gives rise to a triangular figure. See newsletter icon. History at your fingertips. Sign up here to see what happened on this day, every day in your inbox. Email address. By signing up, you agree to our privacy notice. pH Home Science Physics Matter and Energy pH Chemistry by the editors of Encyclopaedia Britannica. View edit History. Full article. pH, quantitative measure of the acidity or basicity of aqueous or other liquid solutions. The term, widely used in chemistry, biology, and agronomy, translates the values of the concentration of the hydrogen ion, which ordinarily ranges between about 1 and 10⁻14 gram equivalents per liter, into numbers between 0 and 14. In pure water, which is neutral, neither acidic nor alkaline, the concentration of the hydrogen ion is 10⁻7 gram equivalents per liter, which corresponds to a pH of 7. A solution with a pH less than 7 is considered acidic, a solution with a pH greater than 7 is considered basic, or alkaline. Alkaline testing. Alkaline testing. See all media related topics. Model pH diagram. pH meter. Isoelectric point quinhydron electrode. The measurement was originally used by the Danish biochemist S.P.L. Sorensen to represent the hydrogen ion concentration, expressed in equivalents per liter, of an aqueous solution. pH equals -log H plus. In expressions of this kind, enclosure of a chemical symbol within square brackets denotes that the concentration of the symbolized species is the quantity being considered. Earth's environmental spheres. Read more on this topic. Biosphere. pH. The relative acidity or alkalinity of a solution is reported by the pH scale, which is a measure of the pH scale. pH scale. The fundamentals of acids and bases and how the pH scale is used to measure them. Copyright American Chemical Society, a Britannica publishing partner. See all videos for this article. Because of uncertainty about the physical significance of the hydrogen ion concentration, the definition of the pH is an operational one, i.e., it is based on a method of measurement. The U.S. National Institute of Standards and Technology has defined pH values in terms of the electromotive force existing between certain standard electrodes in specified solutions. The pH is usually measured with a pH meter, which translates into pH readings. The difference in electromotive force, electrical potential or voltage between suitable electrodes placed in a solution to be tested. Fundamentally, a pH meter consists of a voltmeter attached to a pH-responsive electrode and a reference, unvarying, electrode. The pH-responsive electrode is usually glass, and the reference is usually a mercury-mercurous chloride calomel electrode, although a silver-silver chloride electrode is sometimes used. When the two electrodes are immersed in a solution, they act as a battery.